All right, so we want to solve this polynomial inequality now, right? X times x plus 3 quantity squared times x minus 2 less than 0. So what does this mean? Remember, this is the actual function, right? So if you plug in the x values, right? If you plug in the x values, the answer is the y value. Okay? So we are trying to figure out, okay, what are the values of x so that the y values are negative in this case, right? Because that's what less than 0 means. Okay? Now, graphically, that should be the part of the graph that lies below the x-axis, right? So if we draw our basic xy graph here, right? Remember, every value here, right, is below the x-axis. The y value is negative, right? No matter what point you pick, right, the y value is negative. That's what this is asking us here. Okay, so how are we going to use the polynomial to answer the question, though? Okay, well, the graph is going to help us out, right? So first thing we should do is get the degree of this polynomial, right? So the degree of this polynomial here is going to be 4, right? There's an x times x plus 3 times x plus 3 times x minus 2, so the degree is 4. This is a 4th degree polynomial, right? It's an even polynomial. Okay, where are the roots or the zeros? So we're going to set each factor equal to 0 and solve, right? So we get x equals 0, we get x plus 3 equals 0, and we get x minus 2 equals 0, and then we just solve each of these guys. Notice this is just x equals 0, right? Here we get x equals negative 3, but you notice that in this case the multiplicity is even, right? There are essentially 2 of the same factor here, right? So the multiplicity is 2. Here, if x minus 2 is equal to 0, then x is equal to 2. Okay? So what we can do now is we can plot the end behavior, plot the x-intercepts, and then use the ideas of multiplicities to draw the graph. Okay? So it's a 4th degree polynomial, so we know that this graph should open up and to the left and up and to the right, okay, because it's even, right? So we're going to have our basic U shape, but because it's positive, we're going to go up. We know that we have x-intercepts at negative 3, at 0, and at 2. And then what's going to happen to the graph, right? Well, at negative 3, you notice that the multiplicity is even. So what does that mean? It means we're going to touch the x-axis at negative 3 and then bounce back. Okay. This is the next intercept is at 0, right? So that means we're going to have to turn around. This is called a turning point. And then at 0, the multiplicity is odd, so we're going to go through it. The next x-intercept is here at 2, so we're going to turn around, approach the x-intercept. What's going to happen here? Are we going to go through it or bounce back? Okay, well, at 2, the multiplicity is odd, so we are going to go through it. Okay. All right, so I just did that in behavior there just to help us to figure out what the graph will look like. So let's just do it again here, right? So let's just draw so that it looks a little bit nicer here, right? So this is our graph. And this is our final graph. But this is not the final answer. Remember, what is this question asking? It's asking, right, where are the y values negative? Okay? Which means, what part of the graph is below the x-axis? Well, the answer is here, right? Now remember, this is strictly less than, okay, which means we do not include these 2 points, okay? So this x value is 0, this x value is 2. Everywhere in between here, the y values are negative, right? So what's the final answer here then? The final answer is 0, 2. Right? Remember, this is an interval though, right? It's not an ordered pair. It's not a point. Right? These are the x values from x equals 0 to x equals 2. Right? The y values are negative.